Okay, so from 1J, number 7, this one did say converge or diverge. If convergent, find out what it converges to. So there's no infinity or negative infinity. So where's the improper part? Oh, that's when I go look for the vertical asymptote. I can see from the denominator that 3 makes the denominator 0. So that means at 3, there's a vertical asymptote. So I need to take the limit as t goes towards 3. And if I'm thinking just of a number line from 2 to 3, I'm going from the negative side. And then I'm going to do two things at once here. I'm going to do the u substitution, and only the improper integrals will have at most u substitution. So I get a negative du over square root of u. I'm just going to use this space here. So limit as t goes to 3 from the negative side. So if I rewrote this as negative u to the negative 1/2, whoops, I meant to put t up here. So from 2 to t. Now I'm going to take the antiderivative, so I'm going to come way over here. So see how many times I have to write the limit? It's really important. So then if I take the antiderivative, I get 2u to the 1/2. And before I plug these limits in, you must put the x's back in. So t's are going to 3, so I have 2. Put the x's back in, 3 minus x to the 1/2 from 2 to t. Okay, so here we go. Limit as t goes to 3 from the negative side. Put the t in, so 3 minus t to the 1/2. Subtract, putting in the 2, so subtract 3 minus 2 to the 1/2. All right, so now I'm looking at what happens when I let t go towards 3. If I put t equals 3 in here, I get 0. And then here, I'd get a negative 2 times a 1. So this whole integral gives me negative 2. So that means that this integral converges. Okay, so I want to make sure that you're careful, that you have to write limit all of these times. Every time you don't write a limit, you lose a point. Every time you write a limit when you shouldn't, you lose a point. So be really careful with these limits. Okay, so I wanted to go over one of the comparison test problems of when you don't write limits and when you do. So let's look at K, homework 1K, like number 1. So number 1, it says use a comparison test, and the reason we're using a comparison test is that this integral cannot be done. So you must write the comparison without the integral signs. So writing this function down, x cubed plus 5, no integral signs, and then I'm going to take the number 5 off, and I'm going to say, okay, this is the square root of x cubed. So I can see that this has more in the denominator, so that's smaller. And then let's write this one as an exponent. So that's x to the 3/2. Okay, now it's my job to go do this integral. So I want to do the integral from 1 to infinity of 1 over x to the 3/2 dx. It's the bigger one, so I'm hoping that it will converge because that will mean the smaller converges. So again, I have to write limits. Limit as t goes to infinity, and then I'm going to 1 to t, and then I'm going to take the time to write this as the negative 3/2, so that in the next step, I'm ready to take the antiderivative. So I'm going to bring it over here. So I'd add 1 to the exponent. So that gives me a negative 1/2 times a negative 2. And I'm going to really suggest that it's super helpful to write negative exponents in the denominator before you even go plug in the numbers, the t and the 1. Okay, here we go. Limit as t goes to infinity. And then I would plug in the t, so I get negative 2 over root t plus a 2 over a root 1. Okay, so now go plug in the infinity here. Put negative 2 over infinity, that gives me 0, so I get 2. Okay, so what that means is that this integral converges. So as a result, I can say therefore, and it's necessary to do this, is to say, therefore, this integral converges also by the comparison test.